It's a networking protocol that many different blockchains and as well as ecosystems are moving to. So Polkadot relies on this. I think Ethereum 2.0 is moving towards this. Filecoin, which Protocol Labs is working on, relies on this. Yeah, it'd be fun to learn more about Lib P2p.
Okay, thank you. All right, hello everyone. I'm going to try to present from here, but I need a way to advance my slides. Okay, so I think that'll work well. So let me just give a little introduction, like why is Lib P2p here? What do we have to do with the Web3 track? So basically, I would put it like this: fundamentally, if you've never heard of Lib P2p, fundamentally what we are is a low-level building block for building peer-to-peer applications. So there's not a. Is the sound working? Okay, all right. So fundamentally, so we're not a blockchain. We don't have any token, any economic mechanisms in Lib P2p itself. It's purely just an open source project that aims to build the most useful and most robust system for building peer-to-peer applications on top of it. And as Jack mentioned, Polkadot is or Substrate is one of them. Polkadot relies on that. Ethereum 2.0 is also going to use Lib P2p, so that's another example. And we also have a lot of people building dApps that are not, have nothing to do with blockchain. So we're totally agnostic on what the users want to do. We just want to build the best peer-to-peer stack. So let me. I'll warn you that this talk is probably a little less technical than. I usually give this talk to a less technical crowd, so I'm going to skip through some slides, and what I'm hoping to do by that is create a little time at the end for some discussion. I've already been discussing with some people in the audience some interesting ideas about different kinds of attacks against the data structures that Lib P2p and other similar systems use, so I think it would be fun to kind of dive into that, and other people may have thoughtful things to say. So. I normally start these talks with this dramatic image, and I say, look, where did the internet come from? Well, it didn't come out of a vacuum. It started as an idea about how would people communicate after a nuclear war. Most people would still be alive, but how would, if all of the centralized communication points in the telephone system were destroyed, then how would they coordinate like a resistance or something? And so this was an idea back in the 1950s and 60s, like how do we solve this problem? And that the roots of the internet were basically the answer to that question is build a decentralized network. And then I talk a little bit about, okay, so where is the internet today? And it's basically a lot of centralized services. They're not evil, it's just that it's a lot easier to build something with a centralized database than it is with any kind of decentralized technology. I'm going to skip over these. Here are some things you might remember if you're old that use peer-to-peer. I just want to talk for a second about how Lib P2p differs from like the original generation of peer-to-peer apps, which were mostly like file share, illegal file sharing. Basically, was their goal. First off, we're not focused on that use case. Secondly. Lib P2p is built as a set of composable building blocks. I'm going to talk more about this in a second, but the idea is that you can quote unquote use Lib P2p in a way that does whatever suits your needs. So if you want to use certain modules, you can. If you want to ignore other ones, you can. That's a big part of our design philosophy. So multi-platform and multi-device interoperability, basically the idea there is that this is implemented in several different languages. We have a Go implementation, a Rust implementation, the primary author of which I think is sitting in the back. Yes. Okay, so a JavaScript implementation. We're very close to having a Python implementation. We also have someone implementing Lib P2p in Kotlin, which is a Java dialect. All right, yeah, Kotlin fans. Yeah, so Anyway, the point is, like, fundamentally, this is a standard, and we want people to implement it in many different languages, and the only thing we care about is that they interoperate. And so we have interoperability tests, and we're continuing to build that out. I want to talk about this side for a second because it gets into some things that I think, oh, I guess I should be near the camera. Okay, yeah. It gets into some things that I think are important. So I've already talked about the multiple interoperability implementations. It's, as I said, it's very flexible. It's not specific to a single use case. We also use it as a platform to experiment with new ideas. So, you know, right now we're trying to figure out, like, what should we do about the DHT? Should we use Kademlia? Should we use another algorithm? Should we make it pluggable? So it's very much a platform where you can propose something and, you know, we'll seriously consider it. And in many cases, you can write your own plugins. So I'll show more examples of that in a second. A key principle for us is, well, there are two. One is that peers are identified by solely by the hash of a public key. So we're totally location independent. You can have a device in a Lib P2p network that it has, you know, it is uniquely identified by the hash of its public key. It can move from network to network. It can have multiple addresses. It can have an IP4 address, an IP6 address, a Bluetooth address. We're completely agnostic on what the you know, where the device is. We just know that if it has this identity, then that's stable and that's not going to change. And the private key is used for signing to prove your identity. The other thing is a concept that we like to call connectivity magic. So basically, we try to make a lot of things very easy. So we have features like connection, multiplexing, then within like TCP connection, I mean, then within that connection, we set up what we call streams, which are means of communication. Those themselves have their own multiplexing mechanism. So we've built a lot, and you know, and connections can be upgraded automatically to be encrypted. And so we've built in a lot of things that if you wanted to build a peer-to-peer network on your own, you would have to build these, or you know, or it wouldn't be a very good one. So that's kind of the direction we're going. Like, we try to make a lot of things sort of just work with all the details hidden behind the scenes. So when I say that Lib P2p is made up of modular building blocks, what I'm referring to is the fact that basically these are the blocks. So we have these concepts and these are all abstractions that exist in the code. So we have this notion of a transport which connects two peers over you know, some kind of link. It could be TCP, UDP, whatever, Tor. Other, you know, any connectivity mechanism. You know, we have NAT traversal mechanisms, which is an area that we're trying to build out, but we have some early stuff working there. Peer discovery is another big one. We give you ways to discover peers. That's where this concept of a distributed hash table tends to come in. So very briefly, if you're not familiar, most peer-to-peer networks use a distributed hash table called Kademlia. There are variants of Kademlia, but basically what Kademlia does is define a distance metric between nodes and then connect to nodes that are quote-unquote close, not physically, but close logically, based on this logical distance metric. And it sets up connections that way, and it grows its list of connections to other peers through this mechanism. We're very interested in other ways of doing peer discovery. This is the one that's implemented right now, but it's not. You know, we want to have pluggable discovery mechanisms. Crypto channels, so this is just a kind of marketing way or something of saying that, you know, we have encryption built in for streams and connections. So, you know, you can just basically call a function and your connection will be upgraded to an encrypted connection without you really having to do anything. I'm gonna keep going. Oh yeah, okay, so for each of these, we have some kind of documentation. We're in a big docs improvement process right now, so not everything is perfectly documented, but basically we try to document the interfaces for, these different building blocks that I showed you on the last slide. And yeah, and then you put these pieces together however you want, you get Lib P2p, okay, great. We also have a Google Doc that you can find in that GitHub issue where we're trying to sketch out all of the ideas that we might pursue in the next several years. Some of them are pretty far out there. Some of them are kind of obvious, quick wins. I'm not going to go through that whole list, but I would encourage you to check it out and give comments about which would be useful to you. That's really useful to us. People ask this question, how does Lib P2p, how is it similar or different to the OSI 7-layer model that appears in like networking textbooks and then never in real life? Let me just give a quick answer for that, and then if people want to delve deeper, we can. This OSI model, first off, it's not very accurate, so then people have proposed other models that are more represent how the internet really works. However, these models have limitations, which I think, yeah, okay. So there's two big ones that we saw when we were designing Lib P2p. One is that there is duplicated effort between different levels in the stack. So an example might be something like HTTPS running on a VPN, an IPsec VPN. So it's like there's encryption at the IP level, but then there's also encryption at the application level, and they have no way of the presentation level, the browser has no way of telling the IP level, hey, I'm already secure, you don't need to encrypt, so you end up repeating operations. I'm sure you can probably think of a dozen more examples like this. And then, related to that is what I was just saying, there's this inefficiency between having multiple layers. Building blocks in Lib P2p tend to span more than one layer. They're kind of indifferent to this OSI model. So Lib P2p was born out of IPFS. If you don't know what IPFS is, it's the Interplanetary File System. Basically think of like something like Git meets BitTorrent. So it's content addressed, but it's peer-to-peer in the dissemination of information. And I'm not going to talk about it, but it is a major project for my employer, Protocol Labs, and it's been one of our biggest successes. This one way to look at it is that IPFS is a content address system where you can find content anywhere on the network just based on its hash. Another way to look at, and then another way, an analogous way to look at Lib P2p is that it is a method of process addressing. So wherever the process is running, it's findable on the network. So this, I've already talked about this, multiple language implementations. One cool thing about having a JavaScript implementation is that it runs in browsers, obviously. There's a limit to what we can do in browsers. We can't open like UDP sockets, for example, which is really, really unfortunate, but probably isn't going to change in like the next 5 years at least. However, we can do a lot of things, a surprising number, and so what this gives us is a benefit on any mobile device as a web browser. They all support the same standards, so we can run Lib P2p in web browsers using the JS Lib P2p implementation. We have a lot of contributors. We have a lot of friends on GitHub who've contributed or open issues. I hope that this talk will help us make new friends. Let's see. Just as I mentioned, Ethereum 2.0 is going to use Lib P2p. Polkadot already uses it. Ethereum 1.0 might even use Lib P2p. That's still up in the air. So here's Gavin Wood saying positive things about us. This is awesome. Here are some of the people who have built applications on top of Lib P2p. LivePeer is cool. It's like a peer-to-peer streaming system. OpenBazaar is really cool. It's like eBay for the decentralized world. And this is the obligatory "you should join us" slide. I'm going to go through a lot of this fast. If you want to learn more about Lib P2p, go to one of these URLs. As you can see, they all follow exactly the same format. The only difference is the whether it's JS Lib P2p, Go Lib P2p, or Rust Lib P2p. But either way, you'll find a set of examples. And also github.com/libp2p/specs is where we keep the specification. As I've mentioned, the goal of Lib P2p is to have an implementation, have multiple implementations that interoperate based on a spec. So these are good resources to check out. Okay, so let me see where we are in time. Okay, we have 15 minutes left, so this is what I'm going to do. I'm going to show you a short demo. I'm not going to get into the code behind the demo, but I'm just going to present it to you, and I'll explain what it's doing. It's a canned, pre-recorded demo, so it won't fail. And then after that, I'd like to use the last 10 minutes to try to just open this up and, discussion, questions, criticisms. I would love if people would engage like that. So here's the idea behind this demo. I wanted to write a demonstration application that used all four of the languages that were, all three of the languages that are kind of most complete. So I wrote a program that, okay, so this just illustrates that we have a lot of documentation behind this demo, and you can go to, so if you go to this repo, that's the README you'll see, and it explains in great detail how to run it and how to use it. Fundamentally, this is what the demo does. It's very simple. There are three peers: a Go peer, a JavaScript peer, and a Rust peer. They all start out by connecting to a single Bootstrap server, which is also written in Go, but is not an important detail. And then once they're connected, they use PubSub, which is one of the abstractions we provide, to send just like a basic text string to each other. So let's see if this video starts automatically. Or do I have to press like spacebar? Oh yeah, okay. So the top left window is the Bootstrap node. It's going to start in just a second. Oh, I guess it's going to compile first. Now it's going to be started. This is, again, is just to give the other nodes a point to connect to. So that has started. There's a weird thing blocking some of the text, but basically that's specifying a pre-generated key pair. And that's kind of all you need to know. So now we've got the Bootstrap node running. Now we're going to go to the top right window, and you're going to see the Go peer, which will be started. It will connect to the Bootstrap node. And then the same thing is going to happen in the bottom left window, which is the JavaScript peer in Node.js. It's not a browser. And then the fourth window is going to show you the Rust peer. And then they're all going to communicate. So for example, what you see in the JavaScript here is it's specifying the address of the Bootstrap node. And as this goes, you can see in the top left window that the Bootstrap node is getting these connections, and it can see who's connecting to it. And then finally, the Rust peer is connected. So now all three are connected, and one of them is, I think the top right window is going to type some hello world kind of thing. And you can see all four of the windows got that message. That's because it's using, they're all subscribing to the same topic, so of course they all get the message, including the Bootstrapper. And every other peer can also send a message that's seen by all of them. There's nothing particularly special about PubSub. Like, it's just one of many abstractions that we offer, but I needed sort of something to demo, and it's a pretty easy one to understand. All right, I think that the video ends in a moment, and then that's going to be the end of the part where I'm talking. And all the code for this is available in that repo I showed you in the beginning. So you can play with this, and it's extremely simple. It's not, it works out just a tiny fraction of Lib P2p, but it does show the three languages interoperating. Okay, so I press this. Okay. Yeah, and then it's just like, thank you. And then what I would like to do now is have we have 10 minutes left, some time for questions, discussion, debate. Yes. Am I supposed to? Okay. Great. Okay. There's a gentleman back there.
Coming up.
So in so in TLS 1.2, there were many downgrade attacks and things, and you guys do use this. You guys use, and well, I know you use multi-hash in Lib P2p, and you may have other sorts of things like this. Would it be reasonable to sort of excise this from the code base so we can get rid of those kind of threats of downgrade attacks, try and move to a protocol, a versioned protocol instead of something with this kind of cruft lying around?
Yeah, that's an excellent question. The answer is yes. So I'm going to comment on this, and then I also want to get, Raul is the tech lead for this project, so I'll let him comment also. But basically, yes, our cryptography, including the authentication part, is currently implemented in a module that we wrote. This is like roll your own crypto. This approach never really works that well, but it's called SecIO. We want to get rid of SecIO in favor of TLS 1.3, which is not, if I understand correctly, it's not finalized yet, but the advantage of it is it works really well for peer-to-peer because it doesn't have this notion of a client and a server. It's just like two machines can connect. Do you want to add anything?
So I just wanted to add that at the same, the problem is always the same, which is the technical debt and backwards compatibility, right? So if from a project that is trying to define a canonical model for hashing and a dictionary for hashing and a pluggable format for hashing and so on, you remove hash functions that might be in use out there, then you're going to see errors in runtime. So removing those, I agree that insecure stuff should definitely be removed, but it should be done in a control manner and, of course, in a version manner. And in terms of 1.3, yes, there is currently a proposal in the Lib P2p community to adopt TLS 1.3, and it does some interesting stuff regarding how we generate a certificate and how we embed a proof of the peer ID, because the way that we model identity and keys in Lib P2p is different to the way that TLS does it. So we need a way to link the identity behind Lib P2p with the way that TLS allows you to transport an identity. There's a proposal in the specs repo, and as well there are some efforts of looking into noise, WireGuard, and so on, and other things, and I'd be curious to talk to you guys about that as well.
Yeah, so I'll let you choose, Jack. I think he had his hand first, the guy in the black shirt.
Should I pass it? Thank you. So there's I noticed that there's a signaling server to do the handoff of the connection in between the peers, right? Is there a plan for setting up a system of signaling servers that would allow to do those handoffs in a more decentralized manner?
I actually don't think there's a signaling server. Yeah, for hand. Oh, for. Oh, for browsers. Yeah, okay. For WebRTC, you're talking about that specific case, or?
Yeah, the Bootstrap node that you used, right?
Oh, yeah.
Sorry.
So, okay, so sorry. Yeah, no, that's a good question. This demo assumes a centralized bootstrapping node because it's the easiest thing to implement. What we use in practice actually are centralized bootstrap nodes primarily, but we would like to add other discovery mechanisms that eliminate the need for any centralized infrastructure. And yeah, it's kind of a band-aid, but at the same time, it's very difficult to bootstrap yourself on a network if you don't trust anyone or don't know who you can trust.
Could you talk briefly about the state of specifications? And with that, I mean sort of in terms of making a machine readable, and let's say I want to write my own implementation in NIM, like what sort of, how high of a priority is that, and sort of how do you think about it? Because there's lots of different components, so how do you think about that, and what's your plan for that?
Yeah, so philosophically, we would like to be spec first. Like, we'd like to have really tight specifications, and then implementers, may, must, should, whatever, follow them. In practice, it's not where we are today. I think the specs repo is a good sort of explanation of Lib P2p, but it's not an RFC. So yeah, we recognize that as a defect that needs to be addressed, but we haven't yet.
Yeah, so ideally, it's completely what Mike said. We want to get to a point where you can just read the spec and like understand what you need to implement. First of all, to interoperate with other nodes, and second, to embody the spirit of Lib P2p in terms of, the principles of Lib P2p. So, so that you can call something Lib P2p following the model of Lib P2p in terms of pluggability, in terms of, the system. That's also something that we need to define. Lib P2p, as Mike said, the history of Lib P2p is that it was extracted from IPFS. So we are at that point where we're trying to now, Lib P2p is definitely a top-level project that is being used independently in many other downstream projects, and we are at a point where, hey, we're now recognizing that this needs to be spec'd out, right? It's not so it's kind of like bridging that gap, and we're getting there. Yeah, it's difficult. It's a big backlog of stuff that we need to spec out.
In fact, two short questions. One, do you have any primitives in Lib P2p to build up RPC servers? Maybe then let me just ask the second question. In your example, in the demo, the JavaScript client, they had the IPFS parameter. If you can comment on that.
Yes, I can address that. Yeah. Okay. So yes, building in some kind of RPC system is something that we're very interested in doing. It does not exist yet. It's one of many ideas that's in that Google Doc. If you go back and watch the video of this, it's issue 60 in Lib P2p/Lib P2p. On the second point. So the question is, what is the status of RPC? I would say it's at the idea stage. No speccing or implementation has been done yet. Sorry, now I forgot your. Oh, you were asking in the demo. Yeah, sorry, I forgot your second question. Yes. That's a historical relic. So we use multi-adders to identify a peer, and this is a format that Protocol Labs created originally for IPFS. So right now, IPFS is embedded in every multi-adder. We want to switch to /P2p, a generic one, for demos like this that have nothing to do with IPFS. So it's kind of, it was a good catch on your part, but it's kind of unfortunate. Good question. So we have this notion of multi-formats, which are self-describing byte formats, where there's a header that identifies what the thing is, and then there's some stream of bytes that are interpreted depending on what the header says. So we have addresses in this format. So there's a byte at the beginning that's like, this is an address, and then, yeah, and okay. And so what you saw was actually the textual representation of a multi-adder. The real representation is compact binary, yeah.
So the idea behind a multi-adder is that the protocol doesn't need to state that a particular field is an IPv4 address, and it will remain that way forever, because that can change in a world where transports are pluggable, and you can find peers across different communication transport methods, whether it's IP networks, whether it's Bluetooth, whether it's radio, whether it's a different mechanism. That part, the way that you address a peer, that you locate a peer, should be flexible enough so that that can change over time, and it can change dynamically as well. So we're not, multi-adders is a way of not embedding a particular field as IPv4. Oh, and then later we realize that maybe we want to deal with IPv6. So we need to create another field because we can't extend the previous one. And then suddenly we want to incorporate Bluetooth in the protocol. So now, so it gives you that flexibility, essentially, of self-describing locators on a network.
I have a feeling we're out of time because Jack is like typing. Oh, you're fine? Okay.
Okay, so just quick.
Oh, okay.
Quick note with it. I work a lot with the IETF, and I think Lib P2p would be a great IETF spec, and TLS 1.3 is done, but noise may be more interesting for your particular use case. That being said, so it sounds like the big advantage of Lib P2p is, which is the correct design, is we've separated the identifier of the node, it's a hash of a key from however we discover it and whatever transport we're using. Do you have any key management? Like, what if I want to change my key? How does that work in Lib P2p? That's always really tricky.
So far, that is left up to the application that's using Lib P2p. So Lib P2p, when you call out to Lib P2p and you construct Lib P2p, you pass in a key that will be your identity. So it's left up to the application itself. Yeah. But I'd be curious if this is something that could be a service that Lib P2p offers in a pluggable manner. It could be a facility, if it's commonplace, then it could be something that potentially could make it into Lib P2p for standardization, yes.
Okay, so it's been 30 minutes by my count, but I guess they're having trouble with the laptop. By the way, sorry, just going back to the NIM question for a second, I just wanted to add, I think we'll have a chance to talk to you guys more, but we would really like to help, and if that means like leveling up the specs, we can do that. Basically, the de facto spec right now is the Go implementation. It's like the reference implementation, yeah. So most people who implement Lib P2p basically end up reading the Go code. All right, keep going. Okay, one more question, anyone? Oh, this gentleman. Yeah. I was just going to give it a quick feedback.
Yeah, just a quick feedback. I just wanted to confirm what was said earlier about this peer discovery. As somebody who's like pretty new to networking, and like if you want to make a simple demo, it's really useful to have a simple peer discovery mechanism. And especially like if you're trying to show decentralization, going through a bootstrapping node is not so great. Although I do understand like why you would want that, like for security reasons. But yeah, that's all I wanted to say. Like discovery is important.
Yeah, I mean, so we've just booted up this documentation project that's going to work on usage examples, better highlighting the examples we already have, better explaining them, and so peer discovery is something we would want to work on. I mean, my thinking is that basically the documentation should be robust enough that you can go from basically zero knowledge to being able to write a program on top of Lib P2p. I think that's how most other libraries are. So.
Also wanted to say for a simple demo like this, you probably, on the same machine, you probably could use local DNS, for example, for discovery, or MDNS for discovery. But there are, of course, like if you go out to the network, and you want to bootstrap, at the end of the day, unfortunately, I haven't found any discovery mechanism so far that is addressing peers across networks that doesn't rely on a bootstrap mechanism somehow. Over time, you could avoid that bootstrap mechanism if you've had a successful boot up at one time, right, at a previous point in time, and you store peers that you've discovered in the network. Then the next time you boot up, you don't rely on a bootstrap mechanism, on a bootstrap server. But yeah.
It wouldn't be possible to just like flood all the networks with like a call, like hello, like that's MDNS.
So the reply was that's MDNS. Okay, I guess this is a sign we should keep going. So does anyone else have a question, or do you want to break? Okay, okay. All right, well, thank you very much for coming. If you have more questions, come up and talk to me and Raul. Pierre from Parity implemented Rust Lib P2p almost entirely by himself, so he's a great person to talk to as well. Thank you very much.
Okay, great. Next, we're going to have